The title of this session is 1001 Malbecs, Preserving Genetic Diversity in Argentina. I'm delighted to introduce the speakers for this session. Dr. Adriana Catena. Adriana is a historian and fourth generation vintner at Catena's Apata Winery. In 2009, together with winemaker Alejandro Vigil, she founded El Enemigo Wines in Mendoza. She holds an MPhil and DPhil in history from Balliol College, Oxford, specializing in the early modern Iberian Atlantic. Adriana is joined by Sebastian Gomez Talcuenta. He's an agronomist from the National University of Cuyo and has a PhD in sciences from the National University of La Plata. They're also joined by Silvina van Houten, who is an agricultural engineer from the Faculty of Agricultural Sciences at the National University of Cuyo and is currently completing her master's degree in viticulture and enology at the same institution. So they're no slouches, this panel. They are going to talk about a really fascinating and impactful project centered around the massal selection of the biodiversity of Malbec. This is part of a research project undertaken by their Catena Institute, and they've worked with very old vineyards whose genetic diversity was at risk of being lost due to the uprooting of these vineyards through low profitability. So this is a different aspect of the value of old vineyards. This is a really impactful and interesting project, and I'm delighted to hand over to the panel. Okay.
We're just waiting for Adriana to
Oh,
join.
yes.
Here she can.
Oh, yeah. Thank you, everybody.
I'm sorry, I'm just hopeless with technology.
Don't worry. Did you hear my introduction?
I did.
Yeah.
Yes, thank you so
how
much.
amazing you all are.
That was a very, yes. Thanks for introducing us.
My pleasure. No, my pleasure. Thank you for joining us and for this work. And I give you the floor to tell everyone about it.
So I'm wondering how I share my PowerPoint. Do I just share? Do I have? Am I allowed to share?
If you look at the bottom of your screen, there's a green square with an arrow pointing upwards. And if you click share and have your PowerPoint open, click share, and then it will give you a window from which you select your PowerPoint that you want to share.
Okay, I think, let me see. Sorry, guys. Sorry, everyone.
That's all right.
Success. Do you see a PowerPoint here?
Yeah, that's great. And then if you go to...
I think I've got it.
You got it. You got it. I'll leave it to you.
Apologies, everyone. Well, hi, this has just been fascinating. I think we all love old vines, and this is such an excellent, occasion for all of us to get together and discuss our love and, how to continue this very important work that I think so many of us feel very passionately about. So what I'm going to do today is I'm just going to give you all, as you heard from the introduction, I'm a historian. So I'm going to just do a very brief historical context of Malbec in Argentina, and then I'll pass the mic to Silvina and Sebastian, who have been doing some really, really fascinating and important work saving 1001 Malbecs. We use this title because I kept thinking about Malbec as Sherazad, someone, that you could ultimately save. So let's start at the beginning. This is a historian slide. So this is the Colombian exchange. And I think it's good to just remember just how quick this transfer of the vine was to the Americas. It's really fascinating how the Spanish, they have citrus trees there within a few years of the conquest. But, at the top of the list, the most important thing for Spaniards was to have bread and wine. And so one of the first things they introduce is the vine. The vine is in Hispaniola, I think, by 1506 or maybe even earlier. And from there, it's going to make its way to South America very, very quickly because it is that important. There is a sense that without wine and wheat, there will be no conquest. This is Gil González Ávila in the early 1500s. And so what we have is that by the 1570s, we have a lot of people, a lot of travelers. I think Derek mentioned that there's vines in Chile by 1548. And by the 1570s, people are speaking, and there's different sources that will relate this, but essentially the idea is that the best wine in the Americas is made in the Andean region. There is a sense that the quality of this wine and the amount and the volumes that they are taking are absolutely huge. And you can see this in registers from in domestic shipments, but also, of course, the Spanish are shipping wine across the Atlantic. So there's a lot of competition there, which is going to limit the spread of vineyards in some measure, but not enough. So I think this to say that when we think of the New World and the Old World, I think it might even have been in this conference that a Chilean producer said, vines we had vines for 200 years before Australia was even discovered. And we don't use the word discovered anymore, but I do agree that it's important to think that when we have this many vineyards in South America, Cabernet Sauvignon doesn't exist. That's a 17th century varietal. So it's a very long history of the vine in the Americas. And this is, as I think Derek also mentioned, it's going to be mainly criollas. It's going to be, the Spanish País. These are the grapes that are going to be grown until the mid-19th century. And then we have the rise of ampelography, and we have to think about the communications between the Americas and between Chile and Argentina and Europe. There's a lot of exchange. That's the moment when ampelography becomes a lot more, the rise of ampelography, the popularity of ampelography. There's a lot of transfer of knowledge across the Atlantic. There's circulation of this technical knowledge and these new ideas about viticulture and about winemaking. And all of this is going to travel. And so we have the foundation of the Quinta Normal de Santiago in 1841. And from there, so this is the first introduction in any. And there's always, of course, the illegal trade is always fascinating to historians, and it's something that you can't see in the sources, but is happening through different evidence. So it's very possible that people had brought varietals, European varietals, well before the mid-19th century, but not in any significant quantity. Like this is definitely marked as the beginning of these other varietals in the Americas. And then we have this very there he is. There we have this very curious character, and this is the father of Malbec in Argentina. And I want to pause on him for 1 minute, just because I feel that whenever people talk about him in Malbec Day on April 17th, all Argentine embassies discuss Michel Aimé Pouget. And he's a Frenchman, and he's going to go to Chile first. And from there, he's going to cross the Andes into Argentina, which is where he will eventually settle and marry and have a small plot of land and take over our Quinta Normal de Agricultura, which is going to be the beginning of everything. But what I love about this guy is that he's completely crazy. He reminds me of something like a natural winemaker today. And he's sort of like going into his neighbors' estates and grafting. He's a grafter. That's what he's showing in this photo. This is a carte de visite from the 19th century that were very popular at the time, and you would show what you were best at. And he doesn't have a vine there, I think there's something like a cherry tree, and I'm not sure what he's grafting onto it. If anyone can tell me, I would love that. But essentially this man thought of himself as an expert grafter, but he's also very well known for sharing plants. People would go to his house and he would give different people, he would give you a sarmiento, a shoot of anything that you asked for. So he was very generous as a mentor to other would-be winemakers in Mendoza. He's also going to introduce apiculture, which I absolutely love. So the Italian bee is going to make its way to Argentina because of him. And Pouget's secret there at the end of this slide is that he grafted wisteria onto the main avenue of Mendoza was covered in acacia trees, and he grafted wisteria onto it, so it would have these like beautiful purple blooms all across the city. So he's a very special person, and much more than just the father of Malbec in Argentina. But it gives you, I think, to me, when I read this story, there's that connection, right, between what we're doing today and what we're trying to do today and what this man did. There's something that we seem to share, and I think that's I think that's beautiful. So Mendoza is very particular. Mendoza is a high altitude desert, and fundamental to this story, phylloxera, even though it's going to be present in Argentina, it has a very complex reproduction cycle that it's not going to be able to complete. And this means it cannot affect the vines. So even as Puget is introducing all these French varietals, Europe is being devastated by a phylloxera epidemic. And this means, what we often say, that we have all these pre-phylloxeric vines, right, in South America. And this is the reason why. And again, phylloxera is present in Argentina, so we don't know how long this situation can last. And there are other threats today that I will be discussing soon. So one thing that happens in Argentina versus Chile is that Malbec becomes extremely popular. The numbers are huge, and I think Sebastian is going to mention some of the numbers, but it's something like 80% of Argentine vines by the 1870s are going to be, or by the 1880s, are going to be Malbec. And there's a lot of evidence to say, in the words of our winemaker, that Argentina loves Malbec, but Malbec also loves Argentina. And it does, there's different theories, and I hesitate to mention them, but one of the theories about why Malbec becomes so popular in Argentina is because there are so many small producers, because of the great wave of immigration. It's like millions and millions of Europeans and a lot of Italians and a lot of Spaniards who consume a lot of wine. And therefore, there's a big market. There's a lot of demand for wine in Argentina. And these small producers, they prioritize Malbec because it will give them more fruit. It produces a bit more than Cabernet. It's a little bit more resilient, and it seems to do really well in this terroir. And that's the reason why, even in the very late 19th century already, we see Malbec becoming one of the great and most important varietals for Argentina. I think I'm overgoing on the time limit, so I'm just going to go very quickly. This is our family archive, and I'm just going to show you. If you see here, this is from 1916, and you can see. Can you see my? Is this visible? Yeah. Okay. So
Yes.
you can see here uva francesa. So in 1916, we're still just differentiating between French grapes and uva criolla, right? This is the criolla del país. But by 1930, I just love this. I love the material culture of it all. Things can be so beautiful. To consider the textures and the whole haptic situation with an archive, I think gives you that connection to the past. But here in 1938, you can see that already we're talking about Malbec with a CK and Verdot or Petit Verdot, right? So already we're thinking in terms of varietals. And so my great-grandfather was one of these very small producers, and my grandfather had a vineyard. I think we've discussed this several times. Sarah knows all about this vineyard. And this is in Lunlunta, in the traditional area for planting in Mendoza. And from here, we have created, with the Catena Institute, a very big collection of Malbecs. And so this is where at least our interest in the preservation of Malbec began. But what's going to happen is that there is an erosion of all the genetic material when it comes to Malbec from between the 90s and today. Actually beginning in the 70s, a lot of vines are ripped out. Semillon is another varietal that's really going to suffer. There's only about 600 hectares left of Semillon in Argentina, and yet there were once 50,000. So this is so much genetic material lost forever, completely irrecoverable, and it's devastating, when you think about it. It's like the Rhine, it's just really sad. And so this project is very important, and this process of genetic erosion reaches its peak, towards in the 90s. We have the entry as well of more viruses. Argentina had been something of a Galapagos Island until then, because we really had no money. We had a dictatorship for different, geopolitical situations. And so And so it's at that point that we lose a lot of all this genetic diversity. And so now I'm going to pass the mic on to Silvina and Sebastian, who will tell you a little bit about how they're preserving this and what they're doing to save Malbec.
Thank you, Adriana. I will take the control right for a while, and I will return to you soon. Well, thank you for your presentation. Here I want to show you how the human expansion has encouraged on agricultural land just 15 kilometers away from Mendoza city. And over the span of 20 years, we can clearly see the removal of these old vineyards, which are invaluable as reservoirs of genetic material. This process is not limited just to this area, but it's happening all across the province. But it's particularly intense around the city of Mendoza. Unfortunately, there are many centennial vineyards located, making a huge impact on the genetic diversity of the material. The loss of those old vineyards poses a serious risk to the genetic diversity, and this situation highlights the urgent need to act quickly in order to preserve these vineyards, because more of this valuable genetic heritage is being lost. Here we can see what happened in the phylloxera epidemic in France, where we can observe a severe diminution of the surface of the area of the vineyards. And in this one, we can see what happened in that phylloxera epidemic. By the beginning of the 20th century, here at this point, a recovery had begun, but it was with 80% of the French vineyard being replanted. At that point, only 3,100 hectares, remaining of the 2.5 million hectares that existed just 20 years earlier. This represents a major genetic bottleneck where much of the genetic richness was lost, leading to a much more limited viticulture. However, this doesn't mean that French vineyards today lack genetic diversity. Rather, the genetic richness was far greater in the pre-phylloxeric area. Much of that diversity was lost during the crisis, making the pre-phylloxeric period a key moment for understanding the potential genetic richness of French vineyards. And what happened in Argentina? Adriana has already given us an excellent historical review of the arrival of the Malbec in Argentina and Mendoza. And this slide puts some numbers of that story. This data comes from the first wine census published in Argentina in 1936, conducted nearly 90 years ago. It reveals a significant fact. Over the nearly 140,000 hectares of vineyards, 39,000 were planted with Malbec previous 1920. This can be considered the foundation of the genetic diversity of Malbec in Argentina. Additionally, over the course of 100 years, those nearly 120 million plants of Malbec could have experienced countless point mutation, aiding to the original genetic diversity. Furthermore, we must consider the importance of epigenetic changes induced by the environmental factors, which are beginning to be studied and represent a significant source of variation in how the plants express their phenotypes. We have been done some works in genetics of Malbec, and through our sequencing project involving 4 Malbec clones, which later led to the full genome sequencing of the variety, we identified a relatively small number of single nucleotide polymorphism SNPs markers, around 900 across the entire genome of the Malbec. This discovery enabled us to develop a genotyping chip using 41 of these SNPs to assess the genetic diversity of 200 Malbec clones. We identified 14 clone groups, with one of the largest groups comprising 96 genotypes. But many of these clones seem redundant. For instance, 18 coming from one vineyard, 12 for another, 19 for a third one. But 11 clones in the right side are particularly intriguing. These 11 clones came from an old clonal selection project with plants that share the same genetic profile, but were collected from vineyards 200 kilometers apart and established 80 years ago. This suggests that while this genotypic tool is useful, it can also help deepen our understanding of genetic differences, potentially leading to even greater genetic discrimination into the future. Now I will take the speech to Silvina.
Thanks, Sebastian. So in this context, and with a commitment to preserving this great genetic diversity, we started the All Vine project. The project aims to create a collection of 1001 Malbec accessions. And here we have the first two questions. First, how did we select the vineyard? So we started to make some interviews and to talk with our third-party growers and to identify vineyards over 50 years old. And the second one is how can we distinguish the different genotypes present in each massal selection? And here, well, genetic analyses are quite expensive and we will need to carry out a large number of them. So we developed two hypotheses. The first one suggests that selection planted in different locations on different areas for many years have accumulated their own somatic mutations. So we prioritize sampling for more vineyards and take a smaller surface area in each of one. And the second hypothesis is based on using certain phenotypic traits to select plants. We choose phenology as a key trait, and we will make three categories by three stages: flowering, veraison, and ripening. And we will also measure colure, which is a trait that is particularly sensitive in Malbec. So next slide. So we identified 20 vineyards, representing a total of 98 hectares located in Uco Valley. And we can see the age of the vineyard. 40% of them have more are more than 100 years old. And these represent all these vineyards selected represent approximately 155,000 old vines. Well, next. This is just an example of the survey that we will make. Each point or each square represents a vine. The red one are the vines which are sick with some good disease or some viruses. Also the vines that are dead or that are layering or marcotage in French. I don't know how you say in English, if it's okay. And the green one represent which are good and which the vines we take for the material. This in the next one. And in parallel, some public institution and local government will carry on a project similar in Luján de Cuyo, which are the two regions which has more risk to disappear. So it's the combination and working together that we can save this all genetic diversity. Are we capturing all the variability? Certainly not. This is just the beginning. But we are taking the most urgent cases. And the next.
Okay, I will follow. One important thing is the sanitary issues about the selection process, because grapevine is one of the plant species with the largest number of naturally occurring viruses. Many of these viruses cause significant diseases, which is why early viticulture selection efforts focuses heavily on sanitary selection. Today, clonal and sanitary selection go hand in hand. However, there is considerable risk of genetic erosion as a result of this process, due to the loss of infected plants. While sanitary selection is crucial for maintaining healthy vineyards, it also poses the challenge of potentially reducing genetic diversity by eliminating plants that may carry unique genetic traits despite being infected. At the initial stage of this project we are presenting now, we aim to identify plants that are free of contagious diseases because the process of sanitizing infected plants is both time-consuming and expensive. However, we are not abandoning those infected plants. Once we have the tools to conduct a large-scale and cost-effective sanitation procedure, we plan to return to them. We believe these plants still hold valuable genetic diversity that we don't want to lose. Currently, we are working on cleaning the viruses from the collection of the Catena family of cuttings of Malbec, a process that would allow to us to preserve as much genetic richness as possible while ensuring the health and longevity of the vineyards. The number of viruses described in grapevine has now reached 90 species, and this number continues to grow, largely due to the use of genomic tools for virus discovery. However, many of these newly described viruses are not linked to a specific sanitary problem. It's crucial to gain a clear understanding of their role and how they should be managed. In Argentina, so far we have identified 14 of these 19 viruses, and every virus we actively searched for has been found. This highlights the importance of ongoing research to determine the significance of these viruses in viticulture. One question that appears today is that viruses can be friends instead of menace. While viruses are often seen as a threat to vine health, recent research suggests that some of them might not be harmful and could even play a beneficial role in the vineyard ecosystem. The idea that certain viruses could be friends rather than foes is gaining traction. For instance, some viral interaction might help plants to adapt to the environmental stresses or increase their resilience to certain conditions. However, more research is needed to fully understand this dynamic and to figure out how to integrate this knowledge into the vineyard management strategies. Here on the left, you can see the results of a biomic analysis conducted using RNA sequencing on a seemingly healthy plant. Despite his healthy appearance, the plant was found to host a large number of Wilson viruses. On the right, we present an example of a study that examined the effects of an asymptomatic virus on the plant behavior during drought conditions. Interestingly, the infected plants responded better to drought stress compared to virus-free plants. This highlights the crucial role that viruses may play in the plant holobiome, which is a concept that we are only beginning to understand. These findings open up new possibilities for how we think about viruses in viticulture and plant health management. Without a doubt, grapevine must be free from certain harmful viruses, such leaf roll, fan leaf, red blotch disease. However, we must continue investigating the impact of other viruses, especially the newly discovered ones, to better understand their role and potential benefits. Finally, I'd like to turn it over to Adriana for the closing remarks.
Okay, I think I've unmuted myself. That's so fascinating about the viruses. I just love that. So I'm just gonna sum up what we've been saying, because we're a little bit just to make it sure that now we're going to be back on schedule. I hope Belinda really appreciates that. So Malbec suffers a lot with phylloxera in Europe. Malbec is one of the varietals that are hit the most for different reasons that we won't go into today. And in Argentina, we have all the Malbec. We have all the genetic diversity, but that's not a permanent situation, right? That's a situation that's fragile, that's changing, that's at risk. And so our objective today is to save Malbec, right? To save these 1,001 Malbecs. But as we know, when humans, and that's why I started with that, that slide about the Colombian exchange, we bring all sorts of diseases. We move, like the famous, toad case in Australia. Sometimes when humans try and fix things, they make them a lot worse. And so it's really important when you're trying to save something to make sure you're doing it responsibly, seriously, with research, with the data, right? Look at all the diseases here. And I mean, just what cattle did to the Americas is tremendous. If a historian once said, if you looked at the conquest from outer space, it would look like humans were being replaced by cattle. Of course, because of the epidemics and because cattle would thrive in these contexts. So the point being that it's really important to do this work seriously so that what you do is save Malbec and not cause any other harm, and do it in a way that means lasting and permanent change. And in this road, you might find such fascinating things as that viruses can actually be a positive thing. And so it's a collective effort that we have to do in Argentina with this incredible cultural patrimony that we have of Malbec. Thanks, everyone.
Wonderful. Thank you so much to Adriana, Sebastian, and Silvina. And I apologize also for my really poor Spanish pronunciation. It's really intriguing what you say about the potentially positive impact of viruses. It prompted me to just run off and get this book, The Native Wine Grapes of Italy by Ian D'Agata. Have you read this book? If people need to read this book. Everyone should own this book. He's talking about how, in the book, he talks about how there's a preferred selection of Sangiovese among many top producers, even though technically it's not a permitted clone because it is actually virus infected, but it's that there's kind of tolerance of intersection between having some positive qualitative impacts, even though it actually has some viral disease that does affect obviously its physiology. So I think that this is the wonderful thing about the Old Vine lens. It really makes us rethink so many aspects of the world of wine, from viruses to pruning and training and so on. I do have a couple of questions, which is what role do you think plant health plays in the longevity and preservation of historic vineyards? And how are you balancing this knife edge between, just enough virus, but yet maintaining healthy plant material?
If you want, I can take that one. Well, the health and the old of the vineyard is a complex situation because there is a general assumption that an old vineyard will produce good quality wines. But when, as Silvina showed, when you go and examine individually each of the plants, you will find that almost half of the plants in an old vineyard could be dead. So those are positions which are not using grapes. You should focus into the healthy ones and the plants which are in good shape to produce grapes and wine. I strongly believe that a healthy plant will produce better wine than diseased or affected plants. Also, the disease issue is that an unhealthy plant will respond in different ways to different stress. It will not respond as expected to drought, for instance, or to heat waves. So we need to provide to the growers with enough information to a predicted vineyard. We need to provide plants with resilience to the climate change. For me, from my point of view, it's very important the health of that plant, considering viruses and trunk fungus, because they are also very important. But several viruses are appearing, and they are not linked to any kind of disease. And if we expect to find plants completely free of virus, we are discarding a lot of plants, a lot of diversity, and a lot of genetic richness. So we need to start to study what happened with these new viruses and in which way impact into the plants in a very environmental specific way, because there is a relationship between the host, the virus, and the environment in which those synergism is conducted, and we need to clarify that. But in the meantime, we don't want to lose anything about the genetic richness.
Because the genetic diversity is resilience.
That's true.
There's some challenges that we may not even know what they are yet. Yes. Thank you so much for your presentation and for this work. It's been a great pleasure to hear from you, and I look forward to hearing the continuation of the project and, of course, to tasting some of the wines. Okay, so